Alô, alô, testando. Testando, testando.
Tá me ouvindo?
Teste, teste.
Beleza. Vou desligar aqui então. Friends and families, good afternoon. Please take your seats. There are many available. In hybrid events such as these that involve a lot of people watching us online, it's very important for us to start on time. So that we can stick to the schedule and get going with our talks, some of which will be online. So we must respect their time as well. It is a great pleasure to receive all of you here alongside Professor Alvaro Prata, one of our dear organizers, alongside our president, Luis Erkovich, for the Magna Conference. It is a great joy to be able to do it in person, be able to look into each other's eyes, see each other's smiles, hug each other, as much as possible, of course. I have my mask here on hand. It is something truly special for us to be able to be close to each other at this time and be able to promote our dialogue. It is great to see you 3D live. Anyway, we would just like to start with a brief introduction. And following our words, the President will take the floor. Good afternoon to all who are watching and to everybody who is here. Welcome. I would like to echo the words of our dear Professor Glaucius. It is truly a pleasure to have all of you here. These 3 days will be very fruitful for sure. Mr. President, please take the floor. Hello, good afternoon. And good afternoon to all those who are watching online. It is truly a pleasure and a threshold for us to be able to organize such a conference after these 2 years. Not just because of our health reasons, but for us to be able to discuss science in person. And this conference will discuss science for Brazil, and with an outlook for the world as well. The theme is "The future is now." And it is not by mistake that this is being talked about in the Museum of Tomorrow, because this is where we will build our future. These themes are very relevant for Brazil and for the world. We start with biodiversity, a discussion about biomes, biodiversity in general. We will then move to artificial intelligence, which has become more and more prevalent in our conversation, and Brazil needs to have a role in it. And then have a discussion about health, which for sure is also a relevant issue for Brazil and the world. We will have our Magna speeches, our keynote talks, and I would like to thank Glaucius, Oliva, and Alvaro Prata for taking on the responsibility of organizing this conference, as well as the employees of the Brazilian Academy of Science, without whom this would not take place. I will not name all of them, otherwise I would run out of time, but please, I would like each and every one of them to feel acknowledged. Without you, this would not be possible. And more than that, none of the activities that the Brazilian Academy of Science develops would be possible without you. And it is essential work. I will not go long. We would like to get on with our conference. I was with the people from the Navy, and this is our famous excuse that we make up to have 5-minute speeches. We'll see if we can stick to less than that. Anyway, let's get on with the science. The Brazilian Academy of Science, of course, its role and goal is to mainly develop science and aid in the development of science in Brazil, to stimulate young people and scientists and establish standards of merit in science, as well as defending and advocating for science in education. We are aware that to defend science and innovation today is also to defend democracy. It also means to fight inequality in Brazil. And so here we are. Once again, thank you, and thank you to the organizers. Well, the the Magna conferences of the Brazilian Academy of Science are a celebration of science and of scientific knowledge. This one would not be different. Throughout these 3 days, we will be able to discuss frontiers themes that have a deep impact in our lives. The world has been going through many transformations which will bring about deep change, social, political, economic, environmental, and technological change. Out of these changes, we will see many transformations in how we live and will offer opportunities for us as a nation to be able to correct imperfections of the past, as well as being able to prepare for the future. Many of these ongoing transformations are not for the better, however, and identify potentially dangerous changes for life on Earth and the existence of our planet itself. We need to become more and more knowledgeable and be more and more active protagonists in these changes so that they can be for the better, in a direction that brings us towards sustainability and quality of life for all. Science is our biggest ally in this journey, and we need to act urgently because the future is truly now. In this conference, we will explore these ongoing changes under the aegis of three main axes: biodiversity and environment, information and technology, and life and health. About environment, there has been some progress in the mitigation of the catastrophic climate change originally foreseen at the beginning of the century. However, these accomplishments are not enough, and there is still much to do. Our biodiversity, as we know, is extremely rich. However, our economic model has been destroying this diversity and needs to be reviewed. We will discuss the fragility of the planet, and we will discuss possible approaches at the small and large scale to avoid the degradation of our ecosystems and bring about possible future perspectives which are more favorable to all. We will talk about information and knowledge under the axis of digital technology and the intensive data science. We will explore the impacts of future technology in learning and education, as well as in assistive technology which empower people with disabilities. Challenges to fight misinformation will be explored, as well as the impact of information and knowledge in the economic development of nations. Our third theme will be focused on infirmities and pandemics, as well as in health and quality of life. We will go through the learnings that we've had from the recent COVID-19 pandemic, which will help us in preparing for future similar events. We will discuss how precision medicine and other factors associated with longevity have been registered in the genomic data of the elderly population of Brazil. We will also analyze the relationship between food, caloric restrictions, and aging. And in the perspectives of the meaningful extension of life expectancy, we will discuss the challenges of the research in neurodegenerative diseases. These themes are very much interconnected and very current. We will have scientists from all over the world making their contributions under many perspectives, and we would like to thank them for accepting our invitation. This conference will for sure not be one to be missed. Thank you to José Roberto Boasson de Marca and José Lima Silva, who helped us to build the panels for this conference and will coordinate them. And to the academic Luis Savino for his essential support in inviting Maria van Kerkhove, who will talk about very relevant themes on Thursday. Have a great event.
Immediately, I'm going to invite Dr. Mercedes Bustamante, who is going to coordinate the next section, the first section about biodiversity and environment. Good afternoon, everyone. Welcome to the first theme section of the Magna Conference of the Brazilian Association of Academy of Science. After 2 years, we have the opportunity to be here presentially and remotely. The two ways of participation, thanks to science, technology, and innovation, will allow us to combat pandemics and to enhance the ways of remote communication. Today's topic is "The Future is Now." Nothing more appropriate than the fragile planet's biodiversity and environment. I want to thank especially the professors Glaucius Oliva and Alvaro Prata for inviting me to coordinate this section. The climate change is the decline of biodiversity globally is the decisive crisis of our time. It is happening faster and faster than what we expected. We are far from being powerless about this problem. As the Secretary General of the United Nations said, the climate crisis is a race that we are losing, but we can win. The last reports launched in 2021 and 2022 highlight that there is no place in the world that is immune to the climate change effects. The increase of the temperature is increasing degradation and climate disasters and more other issues. And our development models are not adequate anymore. The impact of the cost of climate change and biodiversity demands a collective and bold action. Climate is a multiplier of risks that aggravates the existing challenges. The science tells us that it is irrefutable. It also tells us that it's never too late to fight its advancements, and that will generate fundamental advancements in the society, the ways of we are going to use the energy, the way you're going to use the land to export goods and leverage our economies. There are technological solutions available for more than 70% of the emissions nowadays. In many places, public policies and applications of sustainable technologies has been successful in the reduction of emissions. In the meantime, the solutions based on the nature offer alternatives that add to the efforts of decarbonization in the post-pandemic. And these solutions allow to mitigate part of the solutions and allow us to protect environmental services that are vital, biodiversity and quality of life for everyone. To guarantee a resilient future and fair is a challenging task that requires the participation of civil society, youth, academia, and governments. Today we are going to count on 4 presentations by experienced researchers. The 3 first one will extend their view on Brazil, the view of biodiversity and maritime and land uses and for the conservation and sustainable development. And the last one will be the Magna Conference today. That's going to take us the global overview of the challenges to the mitigation of the climate change. I have the pleasure to call now one of our first speakers, Professor Lucia Loman from University of São Paulo, Professor Beatriz Padovani from the University of Pernambuco, and Professor Rafael Dias Laela from the Federal University of Goiás. We are going to start now with the presentation of Lucia Loman. She's a doctor by the University of St. Louis in the United States in 2003, and she has a postdoc in the Botanical Garden in 2004. She's a professor of the Botanical Department of the University of São Paulo and executive director of the Tropical Biology Association since 2019. Also part of the São Paulo Academy of Science, and her research aims at showing the evolution. And Lucia, is a pleasure to have you here with us. Lucia is one of the major experts in biodiversity, botanical biodiversity in Brazil. So it's a pleasure to have you here with us. Good afternoon, everyone. I would like to start by thanking the Brazilian Academy of Sciences and Professor Mercedes Bustamante for the invitation to participate in this meeting and also to talk about my favorite subject, that is Brazilian biodiversity. It is a joy to be here today, especially sharing this room with Dr. Rafael Loyola and Dr. Beatriz Padovani. The origin of the huge biodiversity that we have here in Brazil, all over the neotropical region, this is a question that has intrigued both botanists and naturalists for a long time. In the 18th century, many naturalists have traveled throughout our territory and throughout Latin America, and during this period they collected a huge amount of organisms and they started our studies of biodiversity. For example, von Martius, it was a doctor, botanist, and explorer who traveled throughout Brazil between 1817 and 1820. And the studies made by him in Brazil originated the Braziliensis flora that was the first comprehensive treatment of our flora. That was a treatment comprised of 40 volumes, and it cataloged 22,000 species of Brazilian plants. Through his efforts and all the naturalist efforts and many researchers in the last 200 years, our knowledge of our flora continues to be very fragmented. In spite of that, we know that ecological interactions as pollination, dispersion of seeds, herbivory, and interactions between insects and plants, and also the geological history, they were extremely important to shape and structure our great biodiversity. Reconstructing this puzzle about the origin of our biodiversity is an extremely complex task that requires a multidisciplinary approach, including information from many different fields of knowledge. Obviously, the ideal is to study all of our organisms, which is virtually impossible, and our studies of biodiversity depends on detailed studies focused on specific lineages that we can use as a model to guide our understanding of general standards of biodiversity. So essentially, these studies of different organisms are the pieces of the puzzle that we can put together in order to understand this overview of the origin and evolution of the biodiversity. I would like to start presenting an overview of the status of our Brazilian biodiversity, starting with the number of plant species that we know and cataloged, and we have cataloged until nowadays. That is about 50,000 species of plants that were cataloged through the project Flora do Brasil 2020. That was a project coordinated by Dr. Rafaela Força from the Botanical Garden of Rio de Janeiro, along with a managing committee that I had the pleasure to participate. This project had about 1,000 botanists in different parts of the world, and throughout 15 years of work, they came up with a list of plant species that were recognized here in Brazil, followed by the description of each species, information about the distribution, images, and information about the ecology of this species. And all of this material is openly available through this portal that allows you to make some interesting searches about our flora. Despite that, our knowledge about our flora is still very fragmented and very unequal. So, for you to have an idea, as part of this project, we cataloged around 16,000 species of plants of the Atlantic woods, 19,000 species of the dry diagonal, and 13 species of the Amazon. But we know clearly that the Amazon has a higher number of species. In fact, a study that we made last year about the knowledge gaps, we identified that in spite of having many gaps in the sampling of biodiversity, the biggest gaps are in the Amazon. Besides the plants, we have here 26,000 species of beetles, 2,000 species of mammals and reptiles, 2,000 species of birds, and 3,500 species of fish. However, in spite of these numbers seem big, we estimate that only 10% of our biodiversity was documented until today. So when we look at this biodiversity that we have here in Brazil nowadays, the first question that comes to our mind is how does that start? How does that come about? What were the processes that took to this huge biodiversity and the peculiarities of Brazil that made this region have more species than the rest of the planet?
To try to answer that question, we've conducted a series of studies to try to understand the origin and evolution of Brazilian biodiversity, and with that objective, we've combined information from different areas of knowledge, including taxonomy, genetics, geology, and biogeography. In terms of taxonomy, we've conducted a lot of field work. During this period, we've collected materials for our biological collections. And these collections, alongside our biomes themselves, are our biodiversity libraries, which are the basis for our studies that aim to catalog the biodiversity of our territory. With that information in hand, so the names of the species and where they are placed, we then moved to our genetic studies, which also includes field work to collect samples, to then extract and sequence DNA. This information is then used to build the phylogenies, which are genealogic trees, which are essential for our understanding of the origin and evolution of biodiversity, allowing us to truly understand the evolution of morphological characteristics and the evolution of this vast amount of shapes, morphologies, and aromas that we see in nature. These phylogenies are also essential for our understanding of the biogeographical history of these organisms, allowing us to understand the movement of species of different lineages throughout millions of years. The third component of our work is geological in nature, and the geologists of our team attempt to answer such questions as what was the climate like in the past, what was our vegetation like in the past, how and when did different mountain ranges form, and how and when our river basins formed. And for that, they collect data from different environments, including stalactite data, which allows us to determine precipitation patterns from the past. And they combine all of this information with information deriving from continuous data obtained from the soil in depths of up to 2.5 kilometers into the earth. All of that information together allows us to understand the full alterations of our biota throughout millions of years, and at the same time rebuild vegetation and climate models for the past. With that information in hand, so taxonomy, genetics, and geology, then we're able to build the biogeographical history of our country and continent. We have to remember that our continent had a much different biota in the past, and really over 50 different dinosaurs have been described in our territory, including apex predators, the fishing dinosaur, the large-toothed lizard, up until a mass extinction event, creating a crater of around 30 kilometers wide. This crater generated an impact which equals 10 billion Hiroshima bombs, which generated a mega tsunami impacting the northern coast of the US, also leading to volcanic eruptions throughout the world, being felt as far as India. This liberated tons of sulfur and acids into the atmosphere, alongside about 425 gigatons of CO2, which led to the formation of a chemical shield, making it impossible for sun rays to reach the soil, which decreased the temperature in 20 degrees throughout 30 years. The result of all that was the fifth mass extinction of Earth, about 65 million years ago, which led about 65% extinction of the species on Earth. Given that historical context, when we factor that into our genealogies, based on the sequencing of various organisms, we realize that the birds originated in South America. So birds all over the world have their common origin in South America about 90 million years ago. However, birds only reached full diversification after the mass extinction, the one I mentioned. So in other words, the absence of the dinosaurs possibly opened different niches which led to the diversification of birds. We saw the same pattern happening to butterflies. This group has its origin in the Cretaceous period, but the major diversification of butterflies only took place after the mass extinction event. In the same way, angiosperms in the same period, but only reached major diversification. So flowered plants only took place after the mass extinction event. And when we look at the fossil records, so for example, the forests in this specific period, the period which preceded the extinction of the dinosaurs, we saw that these forests were very poor in diversity of species. Only 3 different plant families were found in these forests. Meanwhile, the forests that grew after the extinction were much more diverse, which included a vast number of plant families. So putting all of that information together from the fossil records, the phylogenies, as well as our geological information, the data suggests that the neotropical forests formed during the Paleocene, so after the extinction of dinosaurs, and became a lot more diverse during the Eocene. In that period, so we had a continuous tropical forest throughout all of South America. However, around 30 million years ago, in the Oligocene period, we had information from various phylogenies that suggests the beginning of the dry diagonal around 30 million years ago. So in other words, the dry diagonal divided this continuous tropical forest in two, giving origin to the Amazon and the Atlantic forest. This period, in the same period, we had colder temperatures, dry seasons, as well as the forming of the Andes and the Mantiqueira range, which deeply altered all of the air currents in South America, leading then to the formation of this dry corridor in the center of the continent. At around the same time, we see the formation of a series of specializations in plant lineages associated with dry climates. For example, the C4 gramíneas. Despite the dry diagonal having begun its formation during the Oligocene, the biomes that constitute the same diagonal formed afterwards in a successive manner. In other words, the Chaco, we have geological information suggesting that the Chaco is the oldest biome of the dry diagonal, having formed around 23 million years ago. Afterwards, we have information from several phylogenies that suggest that the Cerrado formed during the middle Miocene, around 10 million years ago. And the same pattern we can see in various different phylogenies. And lastly, the Caatinga would be the most recent biome in the northern portion of the dry diagonal, which came about around the higher Miocene. So in general lines, the overview is South America fully covered by tropical forests during the Paleocene, these forests becoming more diverse during the Eocene, the dry diagonal forming during the Oligocene. However, the biomes that constituted forming successfully throughout it, beginning with the Chaco during the lower Miocene, followed by Cerrado in the middle Miocene, and lastly followed by Caatinga in the higher Miocene.
So this is the general overview of how our biotes and our biomas were formed
São
along
bastante
millions of years.
simplificada,
This
né?
is a very
Mas eu
simplified
gostaria
version,
agora
of
então de
course, but now I
finalizar
would
com
like
alguns
to
pensamentos
conclude
sobre o
with a few
futuro da
thoughts
nossa
about the
biodiversidade.
future of our biodiversity.
Em primeiro lugar, é
At
importante a
first,
gente
it's
lembrar que,
important for
apesar
us
dos
to
enormes esforços que nós
remember
temos
that
feitos para
despite the
documentar nossa
efforts that
biodiversidade,
we make to document our biodiversity, our knowledge is still very fragmented, and in average, we describe around 285 new species of Brazilian plants a year. So throughout the last decades, we wrote more than 3,000 species of plants. On the other hand, the studies made by the CNC Flora here in Rio have shown us that a huge amount of species are already at risk of extinction. So half of the species whose risk of extinction was evaluated, half of them are already cataloged as high risk of extinction, including 43% of the species of the Atlantic woods, 30% of the species of Cerrado, and 13% of the species of the Amazon. Among these species that are running the risk of being extinct, we have a lot of high value products as coffee and chocolate. And basically, we are losing these species before getting to know them and even before thinking about their potential uses. As Professor Anthony Abbs from the University of Madison in Wisconsin, the higher the number of species in the planet, higher is the probability of us finding new products, new medications, and organisms that are tolerant to climate change. Biodiversity is our insurance against the environmental changes. When I think about an optimistic future to our biodiversity, I think about many changes that need to be made, including an increase in our research in biodiversity, including multidisciplinary research in biodiversity, which obviously implies more investment in science and technology, so we can accelerate the documentation of the biodiversity and getting to know these species even before they become extinct. And obviously, this information is critical for better public policies and strategies for the management and conservation of biodiversity. Secondly, we need to intensify the scientific openness that is critical to get closer to the society. We need this, and only through the scientific openness we are going to reach the increase of the investments in science and in biodiversity, and many changes in the education in all the levels in a way that biodiversity can become included in many different disciplines in the curriculum, including big history, that is the history of biodiversity throughout time, sustainability, conservation, and so on. Since the primary education and higher education, regardless of the major, mathematics, engineering, physics, or something that should be taught in all the courses. And only through education that we'll be able to engage the youth and society as a whole and a more integration among all the sectors. And this struggle for the preservation of biodiversity We are only going to achieve that if everyone is searching for the same thing. So with that, I'd like to thank the institutions where most of this research was developed, the fostering agencies, the graduate and post-graduation students in my lab, and the team of the Origin Evolution of the Amazon Biotes. That is a project that we have developed in the last 10 years. And with that, I thank you for your attention, and I'll be available. Thank you very much, Lucia, for the excellent presentation and for sticking to the time. I think in the end we have a round of questions and answers. Now we pass the floor after this great presentation about the Brazilian biodiversity and which is showing us how to lose biodiversity is to lose the history. I'm going to move to the maritime and coastal environments. Beatriz Padovani is going to talk about the challenges for the conservation and sustainability. Professor Beatriz is a marine biologist and professor of the University of Pernambuco with doctorate in Australia, and she has developed research in the northeast of Brazil about tropical and maritime fishes and maritime conservation. She's a coordinator of ecological research of long duration with focused on multidisciplinary approaches of the conservation of maritime landscape, and she was a member of the first World Oceanic Assessment of the United Nations, and she's part of the Brazilian Diagnosis Systems of Maritime and Coastal Systems. Beatriz, thank you very much for your participation and welcome. Well, first I would like to thank you. Good afternoon, and I want to thank for the invitation and Mercedes for having invited us to this diverse panel. My proposal here is to bring to you a little bit of the maritime biodiversity in terms of the landscape and how in the liquid environment the processes are presented and interconnected and how this implies to the future conservation. Next slide, please. Okay, I can control that. So the title that I chose is The Diversity of the Maritime and Tropical Landscape and Paths and Challenges for the Conservation of Biodiversity. We are in the decades of the oceans, and every time we have a decades of something, something has a problem. And these decades brings many different numbers that remind us the importance of the oceans. The oceans are always a part that occupies 75% of the Earth's surface and almost 20,000 species identified, which is not a lot with the numbers that Lucia brought to us. And many other numbers here, the numbers of environmental services, the absorption of carbon, the number of people who depend on the maritime diversity. We have to remember that it is one of the last extractivist activities that we in the collectors and explorers. We practice fishing and the collection of maritime species as we practice in the Neolithic era. Of course, with a more sophistication now, but we still exploit these resources with the population that is growing even bigger. And material values, the $3 trillion. This is how much the market brings and how much this system worth. What do we know about the maritime biodiversity and what efforts are being made so we can increase this growth and be able to transform information into integrated knowledge? One of the recent examples is the Center of Maritime Life. That is, for the last 10 years we had a huge number of scientists 2,700 scientists of 80 different countries with many different expeditions who found out 1,200 new species, but with the studies we are going to reach a million. And we found out that 91% of the ocean species were not classified yet. And more than 80% of our oceans are not mapped and known. So the study as it was developed, the map that you can see, with the red dots is bringing the amounts. The blue are the ones that already had the data. In yellow, the data that we made the survey about the existing data, and in red, the data that was obtained. So we can see that there was a concentration of new studies in some areas. And here in this picture, we can see a few topics in a few special areas where the studies were concentrated. And this is a normal pattern due to the challenge to integrate this knowledge and the ecological processes which they are associated with, and the maintenance is dependent. But it's important to say that we know only a little, but we explore a lot. The Food and Agriculture Organization, that besides the agriculture they also includes the fishing, came after the war to solve the problems of the hungry countries. And they came in a moment that the technology during the wars of the vessels and the engines increased. So it was a huge leap in the power to exploit the oceans and technology of detections. And since then, this exploitation has been growing. In the last 30 years, we had a modest increase of 14% of the global captures, but a huge increase in the global aquaculture. And aquaculture is not without any impact in the fishing of wild animals, and 122% in the global consumption of fishing. If we look at the upper chart, we can see in yellow the trend of the global capture since the 50s. We saw that there was an increase in the efforts of fishing. We increased the capture, how much fish we took out of the ocean, but we stabilized in the aquaculture. On the other hand, regarding the sustainability of the inventory that is measured by the maximum throughput and how much I can exploit in a population, and the population can recover with the recruiting and growth, this is dropping. So we don't have unexploited inventory, and the overexploited inventory is increasing. So we have to make more and more efforts to fish and to have these inventories in this status. But even with that, the oceans, there is only one ocean. The oceans are seen as a major source of exploitation. So this is our blue Amazon that has been launched as a technological border of knowledge and how to exploit the technology, but with a highlight to the oil and gas exploitation and maritime organisms with biotechnological value, as the forest with medication and things we don't know yet that we are finding out, and other types of use. So we still have this view of the oceans as we exhaust the other resources and how we can find what is not exploited yet and overexploit these oceans. But there are some paradigms of the maritime landscape ecology that came from the land landscape that was different, and one of the biggest difference is the cubic dimension that we have on the oceans. In the fluid environment, it does not have the gravity as an anchor, and we have a fragmented distribution. The maritime means is mediated by currents that interact with the topography of the bottom and creates process in which the organism has to adapt. and they need to adapt very quickly because of these changes. And understanding these processes is very important to understand how these environments should be managed and these resources should be exploited sustainably. So these are some examples, and then the census of the maritime life gave origin to the OBIS, Ocean Biodiversity Information System, and allows to synthesize the information, and which is very focused on topics and major regions that are studied, deeply studied to understand all this process. And this is a parallel with the ILTOR International Technological Research and the fields of the CNPq that has these study sites, and also brings the idea that we have to study not only the functioning of these systems, but the function of the system throughout time, because they follow seasonal cycles, and every decade or every century that we have to understand how these come about. The last picture here, the red one with a few fossils, this is the study that was one of the pioneers that shows that in 1300 years we are not going to have maritime species in the worst case scenario. I'm going to bring a few examples of research in this framework of the maritime landscape of the fields of Tamandaré, because it brings us to the difficulties of the oceanographic studies and also our successes and practical examples.
So this includes the northeastern region of Brazil, a tropical one, several conservation units where these studies take place. So first of all, we anchored the proposal of the maritime landscape up until where the platform ends. This is where we can study the easiest, incorporating geobiodiversity processes, depth topography, the interaction of maritime currents with the organisms that need to move throughout their life cycle, how that impacts sustainable conservation, and how we can do it. It's important to record and create a cartography of the maritime depths, as well as understanding what is the biodiversity that's associated with these depths. Some local studies can be expanded to a larger area, for example. We've been dedicating ourselves to studying all of these data coming from all over the world in several different levels of detail, and I brought here an example of the Pernambuco Plateau, a region that was studied by JEP. It was mapped, and through satellite imagery, our doctorate and master students, they usually build that work. They create the satellite imagery to see the depths, which is very hard to see. With the technological progress of our satellite sensors, we have been more and more able to penetrate the oceanic depths and see the ocean floor and discover paleochannels, channels which were at lower levels. These used to be rivers. It's a sediment platform, and these are there and have their own role. A way to become aware of their role is to study hydrodynamic interaction systems of the maritime currents with the region elevation. So we have STD points, which are devices that go up to down to the ocean floor, taking various pieces of data, as well as the penetration phenomena of the colder water that rises due to the internal waves that take place in the ocean depths. When the current passes, it forms waves and rides this platform. So it's a break of platform. It creates local processes that nurture the region. This is an example of how that takes place. And from there, we have to start seeing what the ocean floor is like. The use of cameras has developed significantly. There are several different types of cameras that you can insert or remove. You can see here in the video cameras which are dragged by boats. So you can see from the boat what is happening on the ocean floor. And in that way, we are able to map these oceanic gardens, which has so much beauty and is so much more diverse than we previously thought. In the middle picture, we see the different data that's recorded and the channels, all of the biodiversity, so algae, sponges, corals, all of that can be seen in these patches. This region of the platform break, due to its less oligotrophic characteristic, is a region that the fishermen already knew as high productivity regions. And because of the local knowledge of these fisher people, despite not going into the water, not having sounds, they are then able to have a very good idea of the picture of the ocean floor. And we studied special structures, and we're able to identify reproductive sites on the border of the platform, which were not included in the conservation unit because when they were drafted, it just followed the previous studies. So we've proposed adjustments to it. So what can we see in this platform? On the rightmost picture, we can see a concentration of vessels. That's a radar that detects vessels. So fishing is taking place with all of their traditional knowledge. And in the coast, we see the young recruitment happening. And through various chemical elements present in the internal eardrums of fishes that store that data, we're able to detect that they are truly dependent of estuaries. So they're dislocated from the platform and brought back to these estuaries. So we have a perfectly connected systems and various fishing fleets exploring the high productivity regions. So we have to, that is something that needs to be considered. In addition, how is matter distributed between these regions? So carbon, oxygen levels allow us to see the migration of matter throughout these environments, be them wetlands or corals. We see that for various species, as they grow in size, the influence in how they feed, because we are what we eat, right? It changes as they move. So that also brings the signature of that habit beyond the environment where they are. So they take that with them. Another important element is what we can do to conserve. So protected oceanic areas are very highly talked about. There's a vast science that demonstrates the importance of ocean conservation. And the question is, how small can they be to be effective and remain effective, rather? So this is a small reservation of 4 square kilometers, a place of intense fishing activity. We have monitoring, and there was an increase of species variability in that region because of our monitoring. So we see an increase of biomass within it. However, is that increase exported? How can you retain it? Because some species have ontogenetic cycles, others have extensive habits. So we work with telemetry, which is something that in the past it used to be a lot harder. And with it, we were able to see that despite the fact that some of these species were nomadic, for example, they established territories within these areas, maybe because of critical change that we don't see, they see more favorable conditions and there they stay. And 20% is what we call spillover when they leave and are captured in other areas. So despite the fact that we have reservations and conservation regions in the ocean, this is still one of the best solutions that we have in high fishing activity areas. An interesting fact that happened this year is what can we learn from disasters, right? Unfortunately, they have to take place for us to learn from them. There was a large oil spill in the northeastern coast. We have the vulnerability map. Everything that's in red is extremely vulnerable. So it's pretty much all vulnerable. The oil penetrated mainly the estuaries. It's like these regions are like pumps. They go in and they go out. That's why we can't throw sewage into the ocean, because there's this pump-like motion stirring the waste. So the oil penetrated that region, despite the fact that it touched the land, is that microparticles of oil were absorbed by plankton. These were ingested by various species. Which happens with plastic and other materials as well. In the main port of entry of the trophic chain, we have a possibility of contamination by strange particles. That will then have an impact in those who eat that. In the coral reefs, this is something that we can see very easily. This was collected from light traps. And on the GIF on the corner, we used larvae expansion model to see the dispersion and connectivity of oil spreading throughout the coast. As if we dropped particle through a hydrodynamic model and saw what happened. So we see the connectiveness potential there, which is exactly what happened. A simple model, but it worked. Another impact from which we have a lot to think about is the impact of coral reef whitening. They have a very low ability to sustain temperature variability. We saw that in 2020 there were very anomalous temperature changes, and we saw a general whitening in the coral reefs of the Brazilian coast. So massive whitening, and for the first time we saw massive death of coral reefs, because in the last decade was the hottest in record, and in 2010, 2016, 2019, 2020 we have 4 extremely high temperature anomalies. So that led to whitening, the break of the symbiosis between coral and algae, which leads to the death of these species. This is something we've been seeing all over the world. We've talked a lot about coral reef health since the 90s, when we saw that these were starting to be denigrated, because of various pollution processes. At the time, we weren't even thinking about plastic and climate change. So we created a global monitoring network, which also creates periodic reports. The areas that we studied were these, for which we have data, but it's a very large network. And what we saw that happened in Brazil throughout these last 20 years is the same thing that we've been seeing all over the world. An increase in algae, deriving from the increase in temperature, and a decrease in recovery of the coral reefs, however, a significant drop right afterwards. Unfortunately, the recovery after the Great Whitening of 1998 was lost in this new whitening event. So the biggest problem that the coral reefs have today is that the interval between the anomalies is wider and wider. 2019, 2020, we had a heat wave that lasted pretty much for 2 years. So the coral reef monitoring has several advantages. We are part of a volunteer-based global network. There's a lot to be done. Science citizenship is essential. It's much beyond data collection. It's understanding the data. It's about how to use that data and influence their communities. The Global Network report, the final statement was that the loss was massive. The solution is to manage carbon emissions, but also local solutions. We've grown used to land erosion, coastal erosion, heavy sediments carried to coral reefs, sewage pollution for several years, and it's only growing worse. And the other element was restoration, and I will close on that. We were talking about machine learning, right? This is a model, decision-making model through tools, in which we used a coral reef mapping based on bands that are also able to see the data to map coral colonies. It was determined that the distribution of these colonies did not just derive from nature, in their characteristics, I mean, but also from the care in their management, in the well-managed ones as well as in the mismanaged ones. In the areas that we saw low variability, we saw an influence of that balance. And that shines a light of hope into the situation. The pillar of what we've been doing in the forests. Some colonies are resilient. In them, we see the genetic key to find out why they are resistant. We say, wow, we have to save the coral reefs. The coral reefs are sending us messages. We have to save ourselves, because the coral reefs have been around for a lot longer. And information is everything. It's what we need. This is something that everyone has been talking about. And we have very little data about fishing, about what we remove from the ocean. All of that in blue in the coast and in yellow are fishing activity vessels. So you can see that all of the oceans have them. Brazil, which doesn't have up-to-date data since 2008, now adhere to the Global Fishing Watch, which has satellite and radio monitoring. At least the larger sized vessels will be mapped. But we see a lot of gaps in the northeastern region from the time when we only used to map them through satellites.
So we have an invisibility of a sector that has millions of people, especially the most vulnerable to the climate change, because of the changes that is expected by the Maritime Organization of Distributions with the impact of the climate change. And also the features of movements all over Brazil that launched a platform of self-monitoring. The self-monitoring of the fishing does not intend to substitute the monitoring that the government has to make, but it is a tool to give visibility and self-knowledge and exchange information. And we are talking about the species of the catalogs for taxonomy, and their idea is that making this a cataloging with a regional difference, that we have different differences between the states. And to conclude briefly, soon we are going to have the Brazilian diagnosis of the coastal and maritime environment, and as a new thing, which is a view of the PBS, is the participation of local knowledges. The participation of these local knowledges in because they are also threatened by the model that we have that does not allow communication. So this incorporation of their view of these knowledges in the service ecosystem services or what we have to do to make sure they will exist in the future. So soon we will have good news and maybe changing in the look that we have. So I want to thank the long duration work that is a lot of people working. I would like to bring the pictures of the students, but I wanted to limit the number of slides. Thank you. Thank you very much, Beatriz, for the presentation. I think we saw a lot of intersection points with Lucia's presentation due to the complexity of the biodiversity and the demands for different disciplines and areas of knowledge and incorporation of new methodologies for the study of biodiversity. I think Beatriz also mentioned essential points that we are talking about the socio-ecological systems and the interaction with other humans that are particularly important. Now, let's go to the last presentation of this afternoon. We can close with Rafael Dias Loyola, professor of the Federal University of Goiás, who is going to talk about the future we want, our last change to live with biodiversity, and Rafael acts in the interface of science and decision-making process in the elaboration of public policies. He's a consolidated researcher that enters the public policies areas with a lot of courage, and currently he's a executive director for sustainability, which is an organization for understanding the relationship between man and nature and contributing to the sustainable future. He's acting as a scientific director for the Brazilian Association of Sustainable Development and as a visiting researcher of the Botanical Garden in Rio de Janeiro. He's a professor of the Ecology Department of UFG and member affiliated of the Brazilian Academy of Science. Thank you very much. Rafael, the floor is yours. Thank you. It's a pleasure to be here. It's a pleasure to be here in person. So for those who are listening to us through the internet, and it is a pleasure to be here with all these women researchers, fantastic researchers. I am a biologist, and the evil of biology is that everything is very interesting, and it's an agony to choose what you're going to make. Every time I hear these speeches, I want to come back to the classroom to learn more, because I have the feeling that I didn't learn enough. So this satisfaction is to look at the curious faces with the presentation. I think this happens in all the sciences. So it is not a privilege of the biological science. But anyway, I'm here to talk about our topic, that is the future is now. But what future is that? If the future is now, we have to start designing. I think we started in the long time ago. We have a common view of the future, and I am very happy to see that in an important meeting of the BAS and the natural part in the environment comes first. This is the foundation of everything that we are talking about in the future, what that we want ahead of us. I think that my main point, I'm not going to start again. I think Lucia had a wonderful presentation for us to understand where this diversity comes from, and Beatrice complemented this maritime part that for the diagnosis tools. Now that this is relegated, we can see the number of species that we know, but the fact is, and you might have felt that with the time, that this concern is growing. Of course, the environmental concerns with the environmental issues is not new, but this is growing, and lately it has been being highlighted in the press. So with the advance of pandemic and all the interaction that these emerging diseases have with the natural systems and the destruction of the systems, that was even more clear to us. And in the last 2 years of COVID-19, a lot of publications were made, of course, inside the academic sector, but many publications that call our attention to the problem and shows that the environmental issue cannot be ignored anymore. I have been repeating that. We cannot pretend that this is not our problem anymore. We cannot ignore and think that the natural resources, as we learn it at school, are renewable. They are not renewable, and we are exhausting them. And then we have a lot of reports as the World Economic Forum calling the attention to this issue, the climate issue. The report published by United Nations last year is calling the attention to this environmental degradation and pollution and loss of species, as Mercedes said. All the climate things being incorporated by the private sector as well and by insurance companies, saying that there is a cost associated with that, and this cost is very high now. The cost of not doing anything is getting higher and higher. We have more and more losses, and how this integrates in the economic systems in a wonderful report published last year about the economy of biodiversity, the economics of biodiversity, and how the biodiversity is the base for the economic developments that we aim for. And even though this is being ignored so far, from the biodiversity crisis perspective that you also know, in 2020, an international panel on biodiversity that is equivalent to the IPCC, where many of us work, in the global report calls the attention with numbers. That is a synthesis of numbers and work with more than 300 scientists making this type of synthesis for what is happening. And this panel has a way that I like to understand the problem, showing that what is happening has reasons from the past that they call indirect drivers, and these drivers is the demographic and social cultural growth, consumption patterns, and the conflicts and the epidemics and the war. But this is the root that is being reflected in drivers that we call direct drivers. This is what we know. The change in the use of land and sea, and the deforestation, when you are changing the original coverage by another one. Exploitation, as Beatrice just said about the reduction of the fishing inventory. Climate change, that is another crisis. Pollution, and invasive alien species, that are the species that do not belong to a place and they can occupy this place and make the other natural species become extinct. That was called in the past as the four nights of the environmental apocalypse. The climate change was not included in that. But the fact is that if you look at the numbers on the right, that this has led to a huge loss of biodiversity. So in average, half of the natural ecosystems of the Earth already disappeared. If we get our example of the Atlantic woods here, almost 80%, 76 or 75% disappeared, and it's already consolidated with different uses. And the 25 remainings, they have different qualities. This degradation is even higher. In our Cerrado, it's almost 50% as well. But in average, if you get the ecosystems all over the world, 47% is gone. And this is a lot. 1/4 of the species that we know now, and we don't know enough, 25% is threatened to be extinct. So the agony of the biologists is that we are losing species that we don't know yet. So this is the cost of our ignorance. We still also have another serious problem from the environmental problem perspectives that we are losing populations. We are declining the number of individuals in each species. We have less and less fish of certain species. We have fewer bees of a certain species, fewer plants of a certain species. And this is the biomass, and this biomass, since the period that we know that we started to understand the diversity with the existence of the man, already reduced in 82%. That's why we don't have in the Cerrado huge animals as we have in Africa, or hippos and rhinoceros. These species were never there, were never here, but we had similar species that were hunted. And there is an intersection of this natural system with the social system, and the people are being jeopardized and by being harmed by that, especially the people who depend on them and have their way of life associated with this diversity. In the same report, you are going to see that 72% of the local communities or indigenous communities showed that they lost what they had in terms of subsistence. So we are losing not only diversity, but we are losing social biodiversity and cultural biodiversity associated with the use of nature. And from the climate perspective, these crises are synergic. These things are directly related to the other. The problems you already know, more than the biodiversity problems. So remembering that the IPCC, that is International Scientific Organization, gave us a budget for us to spend in terms of the heating of the planet before the catastrophe hits us. So you can increase 1.5 degree. So we are going to exceed these budgets up to 2050. But if we don't exceed that, 221 million people will be submitted to water scarcity. So this is more than the Brazilian population that will be exposed. If we reach the 2 degrees, that what we don't want, but maybe it will happen until the end of the century, more than half of the world population will be submitted to excessive heat situations with death, leading to death. More than half of the gracelands are going to disappear and will not be proper for that culture. And that generates a cascading effect where we have problems with water security, food security, and climate change, not to mention the patterns that are being changed and leading to extreme events, these landslides and rains and mudslides that we had in Petropolis that led to these floodings that we saw. And the main cause of that, I would say that 30% of the whole world of this driver that leads to this degradation is this change of the coverage of the soil. In Brazil, it is called deforestation, but I don't know if it is the best term because we have some ecosystems that are not forests. So this is loss of native vegetation. And this is the landscape. I don't know how much of you came to Rio for this meeting, but what you see from the plane, you see that image for this type of use. But this type of use being made in a way that I want to believe that is old, without planning, without thinking about sustainability that this is going to bring us, this is what generates this insecurity. We are talking about food safety, the cultures. We won't have the production that we have now. This is happening with the soybean, with the corn, and with the beans. And this is also true with natural elements that the biodiversity gives us. And we have in the world 1 billion people, 1.2 billion people that rely on the nature and mostly the forests, without not to mention the marine environment, almost 4 billion people depending on this marine environment. And this has a direct impact for those who live in the cities, of course, because they have to generate energy from someplace. Since in our case, the energy matrix is clean, that this will bring consequences in this loss of coverage for native vegetations, reduce the number of the amount of water in the reservoirs, and that brings consequences to the urban population, especially in a world where 70% of the population might be inside the cities up to 2050. And in Brazil, 85%, if I'm not mistaken, of the population is already urban, according to the last census. But here in the southeast, 93% of the people live in the cities.
So this concentration of the use of resources that come from somewhere associated with how we use them is what generates this environmental and climate crisis, which has social consequences and increase inequality. And when we have a pandemic like the one we saw, these inequalities are only potentialized due to the lack of access to other resources which are not necessarily natural. Now, it's a cataclysm, but there are solutions. Like Beatrice said, when we have the decade of something, it's usually a bad thing. But we have solutions. In the case of biodiversity, the solutions that's being thought about globally, there are various local solutions that we can talk about later. But globally, we're building a great agreement that's being built right now as we speak. There are negotiations being done. I've been part of the negotiations. An agreement of the UN to contain the loss of biodiversity and revert the picture that we've been seeing in the environmental side. The new global marker for biodiversity post 2020. Within a convention, the biodiversity convention. It gathers the member countries in these conferences, just like the climate one did in Glasgow. In COP26 for environment, there is a conference for biodiversity. Also COP, we're in COP15, if we're meeting for a shorter time, which will supposedly take place in China, possibly August or October, COVID allowing. And if you look at what's being built into the agreement, it's a set of goals that we have to meet until 2030 and then 2050 for us to be able to reach the vision that we've been calling the 2050 vision, which is us living in harmony with nature, acknowledging our full dependence on nature for our living, for our businesses and for our governments, as well as a series of publications which you will see in specialized literature as well as in the press. It has been calling our attention for ambitious goals. The goals need to be ambitious. And they're right. They have to be ambitious, coordinated, and they've been using this word that the Academy doesn't particularly like, holistic. But it needs to be part of a system that, despite the fact that at the Academy we can have everybody in their own square, everything is very much connected, and things need to be seen as connected. In this perspective that Lucia brought, that there is a genetic component, but this genetic component is added to the species component, and the species are organized in the ecosystem, and all of that is actually just one thing. That fact needs to be acknowledged, and the lack of that acknowledgement is a lack in the participation of science in these forums. So because of that, you will see works that have been done, and I was part of many of them, in the work of supporting the technical side so they can provide data to the member countries. Each country's diplomats are responsible for these negotiations. And understanding each goal, their implications and ramifications at different levels of biodiversity. So you can have a goal that is to restore 15% of biodiversity, and that has implications for the species, but also for the ecosystem. And there are goals that have genetic implications in terms of genetic species, the use of these species. How can I guarantee that the traditional uses of these species will have the right to do so? these ramifications need to be understood as the fact that we need goals that are complex, however, that they reach all of these levels, and that is not easy. That is what is lacking right now for these negotiations. There's a deadline for it, by the way. Because you don't start something today and tomorrow it's done. When we think about restoring the ecosystem, this will take years. At the simpler level, you could have a better vegetation coverage, but it hasn't been seen in numbers yet. So maybe I'll need 30 years to be able to fully restore an ecosystem. And the Academy has its reservations towards the possibility of even restoring them fully. Another support that has been provided for these negotiations is thinking that to solve such a complex system, we need to have several heads thinking in the same wavelength. So we have a group talking about biodiversity, but we need to understand what people from economics are saying, from the health sector, data treatment, and how all of that can be translated into a political agreement. Management is also an aspect of it. There has been a drive in the literature, especially in the reports and publications, in the sense of translating that content to other decision makers. To not tell biological stories in the scientific context, which are not always understood by all. So these are very simple systems, saying basically, for example, in setting goals, we need to follow these protocols, which in turn follow important biological principles. One being acknowledging limits, which means that we can have solutions, but there are some things which are non-negotiable. Some things are irreplaceable. Some things cannot be put on the table. Not everything is about political discussion. Not everything is give and take, so to say. Coral is an example. Another example is focusing on benefits which provide net results. We have this tendency coming from how we organize our world of creating a plan for something, executing actions, and thinking that that was enough, and not thinking about result assessment. In English, it's easier. We call it result and call something else an outcome. Outcome is the effect that that had, not just whether I did it or not, or the result of my action, but what it generated. We have to focus on these more tangible results. And then, obviously, we need time. The PCC is working on this idea that there is a time interval, there is a budget to be spent, there is a threshold that we need to reach. As it's a little bit more complicated with biodiversity in comparison with climate, COP15 is being called the Biodiversity Paris Accord. And we need to create an image showing a descending curve of biodiversity, and we need to revert that curve and make it rise again, so that we're able to reach positive transformation, gains in biodiversity. It's not just reaching a 0 point, net zero as we call it, but also making it rise. To have a net positive gain. Because of this biodiversity complexity, we have to think about what is the key to biodiversity. When we're thinking about biodiversity, we usually think about tangible things in what we can see in ecosystems and species, etc. But there's a biodiversity you don't see. Genetic is one, and one that we don't often even dream about, which is the evolutional history. And intermediary organization levels, if you go out on a plane, you can have an idea of it. And identifying these variables and knowing what we are protecting and what are the indicators that that is being done is very important. It seems simple just talking about it, but when negotiating with 50, 60 countries with different concepts of what they are calling biodiversity, then things grow a little bleaker. And then we have to avoid replacements which are not interesting or favorable. We have a trend of compensating. So if I lose biodiversity somewhere, I can compensate it somewhere else. I can insert another species, and that's not how nature works. You can't just trade something for something else. If that were the case, it would be great if we could just trade things off, but you can't. This issue of climate and the Paris Accord has brought to light an issue that's very useful for us to talk about, which is ecosystem restoration. We have people who depend on natural ecosystems. We have an environmental degradation level of 1.2 billion, a massive number, and because of it we have goals to recover these ecosystems. We have a specific one here in Brazil. And restoration, which is a tool, a solution for us, it has been talked about in terms of being a solution to this issue. And that is true, because I believe that it is able to make that cross-section. In biodiversity, you can reduce risks of extinction. In climate, you're able to capture more carbon. In economics, later you can sell those emissions. That generates a value chain. You have bioproducts, and then biotechnology comes in. So we start generating jobs. We stir the economy, and then everybody wants to restore, right? So that is why, because it connects all of these different interests. So when we go back to the idea of sustainability and think that I have a natural environment, we have people, and an economic way of living, this is what will make the wheel turn. That's the type of solution that this biodiversity accord has been seeking. That's why we have a specific goal in terms of the origin of these resources.
There is a framework to do this. That is the SDGs, the Sustainable Development Goals. And these objectives, these goals, are already in the economic conversation on how they work. An example is how this discussion about the environmental indicators of governance of the companies, that you're talking about ESG, and the perception of the private sector that this is worthwhile. So you can see in the chart that throughout time, the gain of values of the the companies that are listed in the Brazilian stock exchange with the ones that are not, so that are part of the Ibovespa. So the companies that are listed in the index are having better results and being able to capture more resources and are generating more value to the stakeholders and to the shareholders. So apparently this is a perception that this is important, and preserving biodiversity is a solution and not a problem anymore. But just to conclude, I think that the current trend is we need to have science to support the public policies making or the decision making processes, especially from Brazil and in negotiations with the foreign affairs. And another trend that we will talk about, businesses that have environmental impact. This B system that was created will bring an evolution in terms of integrating biodiversity in the solutions that we are seeking. And I am always optimistic. I think there is a social demand that is more clear about the conservation of biodiversity and the sustainability and the world that is fair and sustainable. It can be a small world, but this is a movement that is growing for everyone to agree on that. Thank you very much for your attention. Thank you very much, Rafael, for the presentation. I think Rafael reminded us about the importance of the science being landed in the international discussions. This is not an easy flight, but it demands the capacity to translate the knowledge for the decision-making process. And Rafael raised another important point that we need to participate more with the private sector in these discussions. Governance is much more than government, thank God, especially in the moment that we are living. The participation of civil society and the participation of the financial and the business sector. I think we have important points. I think Rafael is more optimistic than I am, but our Magna conference is going to talk about the acceleration for the seeking solution by Professor Chris Field. We will have time to discuss that in the presentation. So I have many questions here. I'm going to ask the help of my friends here if you have questions from the audience and some of them that were sent to through the YouTube. So I can start here. So I don't know if I'll be able to read my smartphone screen here. So let's try. So this is a question from Van Dijk Bautista: how to develop a science and technology system for the conservation of biodiversity if the Brazilian society is still thinking that if you plant everything will grow regardless of the investments, and fake news are successful now. So are we to blame so we don't communicate well? So I think it is for everyone actually, but directed to Lucia, who is the first one. But I will add another question that I believe is directed to anyone. What are the bottlenecks that stop the creation of these studies in Brazil? Yes, it is on. Yes. I think that there are many aspects mentioned in these questions here. The first one is the end of the first question is that we are communicating well. I think that during the pandemics, the scientific communication really strived, but I think that this is something that we were not successful in the past because we didn't communicate well this information. I think partially what we are harvesting now has a strong relation with this lack of scientific communication. The second question is about the bottlenecks. Where do you see the main bottlenecks for the research in biodiversity? I think the bottlenecks in research in biodiversity, the first one is resources, because these are research that we need to accelerate the research on biodiversity. Unfortunately, the number of people graduated to identify species and conduct the studies in biodiversity, it is a small number. We taxonomists, we are the only people in the world that is capable of organizing the organisms and identify organisms of those groups. So we have to train the whole teams of people who are capable of identifying biodiversity. And I only talked about plants and birds and big organisms. I didn't enter the microorganisms parts that we didn't even started. The projects of Brazilian flora, the fungi, for example, is a component that we couldn't advance with 5% in the project as a whole, and we need to study many more. I'm looking at microorganisms. There is an expert in the audience. Beatrice, do you want to say something? We have more questions from the audience. Well, I would only add to what Lucia said, but our communication has to be made professionally. So we have to prepare ourselves so it's not the way that we think it works by communicating. I think you needs to have a plan of communication that needs to be incorporated. The spell is trying to do that with a translation to a more accessible language. I think that surely we need to go to this step. And taxonomy is something that needs to be more appreciated by these fields that is reducing the number of people. It is difficult to retain the talents and well graduated people. We have a lot of dropouts, so the investment will become this more attractive. Will make this more attractive and will be competitive in this regard as well. I think that the last points of the attraction is really critical. Everything is connected, so the lack of the perception. We are in a complicated moment to value the science in the country, but the perception that the science is important, that we need to have science, it has to come from the society, but the society will only see if the society sees what the science is doing. And the other points that we already changed, we need to publicize that. We have to know how to publicize that. There is a method doing that. And we need to see this perception that this is something antagonic. And many people, especially those who are in the beginning of the career, they see a problems to allocate resources. If I invest to the public the publication, I will won't have money for the papers, and I have to do both. But we have to study to do both. Okay, but this is a topic for another seminar. I will pass the floor to Professor Glaucius, and I think there is a question, especially about the microorganisms that I had prepared to ask. We are dealing with a gigantic universe that is in the base of the economy, and suddenly a virus stops the world. And something that we don't know that is in the base of the whole biodiversity. And I think that I see that as metagenomics, that the technology can help in this gap of specialized people in taxonomy. Do you also understand that way? Surely, I think this connection with technology is extremely important. Currently, I am participating in a judgment of proposal for the X Prize Award to find new technologies to accelerate the discovery of biodiversity. I can't talk about that yet, but there are many good and interesting things and doable things with relatively low costs. I think this is a key point. This connection with technology, I think it will be very important. And I think that another point that joins the things of financing, for example. Last week I was in another event about creativity, talking about bioeconomy and how a company that has a database of microorganisms that maps these microorganisms to find biomolecules with active ingredients to be used in bioeconomy, and selling that as a reason for funding to attract research will make this middle ground work. I can also answer this question if you allow me. I think that we will continue blocking the base. If you work with biodiversity and microorganisms in the soil, you can collect and make the metagenomics, and you compare with the libraries outside, and the most dominant groups of these samples is not well known because you don't have comparison. You don't have collections enough scanning tropical areas so you can have a sources of comparison. So these are issues that we have a lot of technology, but we demand the structure of field biology, of intensive collection, and systematic monitoring and storing information that has to walk along with the technology. So this bottleneck technology didn't solve. And just complementing, I think that technology will help with the organisms that we already know. But in the taxonomy, the greatest bottleneck is the lack of graduated people and experts. But for the organisms that we already know, technology is going to help us a lot. Good afternoon, my name is Alexandre Guimarães Vasconcelos. First, I want to congratulate you for the brilliant presentations. And all three speakers talked about the anguish of being many times having the extinction of species without even getting to know them, without the science knowing and the general population. And there is a disconnection between the knowledge that is being produced and how this will reach society and how this will reverberate in public policies. So I would like to hear from you, what are the paths that you are finding with the public administration and the government to take this message to COP15 of biodiversity? And how do you see the possibility of building collective pathways in the scientific community to make this message go across the public policies and to be accepted in terms of public policies in our country? I think that one aspect we need synthesis. We have a lot of things to be discovered and to be documented, but we have a lot of knowledge as well. And our synthesis is extremely important. So an excellent example is the Science Panel for the Amazon, which is an initiative that many of us is involved, and that produced a thin synthesis of the knowledge about the Amazon, including biodiversity, geology, social aspects, possible solutions, bioeconomy. And I think that this type of synthesis is key to take the information across. It is a group of 200 researchers, and the information produced in a tangible format, including information, and there is a report, and then participation of the media and people with different audiences. I think these syntheses are critical right now. And I think that taking this information and debating them, not only with the government perspective, but the municipalities in the states and the environmental defense councils in the environmental basins, and with this participation of the civil society and the governments that are making decisions, even though they are not deliberative, but the possibility to change that, to bring society to request more, because without this request from the society, it is only when there is a goodwill of doing things for some reason. So this transformation is very important. It seems like we agreed before, but I think that the way that we found, it's not only in Brazil, it's also in the world, we are importing that. It is to bring this diagnosis with this other language. This organization in the IPCC and IPCC here in Brazil, we have the Brazilian organization of biodiversity. This is classified as frontiers, so they are not making science, they just translate the information in order to influence decisions. And by taking this information ahead, there is a process of hiring communication team, designers making the best info charts, and journalists who revise the text and the language of the text. And these organizations that makes this bridge between the knowledge and those who are going to make the decisions, I think it is being, as the example of many countries in these international forums, the best mechanisms that we found to take this conversation up. So these public policies are designed with the influence of science. And on the other hand, which is interesting, with a lot of humility to show that this is one more layer of information, that the science has a lot to offer, but this knowledge does not come only from the science. There is the knowledge from the traditional communities and from religious groups, and in these forums, the conversation is more plural, it's more diverse. But it is the best way that it has happened in Brazil to take this conversation further to the decision making process and for those who are designing international and national public policies. Unfortunately, we don't have a lot of time now. We have questions from Valgo. We have a lot of questions from the internet. A lot of people want to know the situation of the areas that you mentioned. We are going to request more room for this topic because we saw that there is a lot of room for discussion. So we can close with Adalberto's questions. Thank you very much, Mercedes. I was fascinated with the three presentations. Thank you very much, all of you. My name is Adalberto Val. I work at the INPA, the National Institute of Research in the Amazon. And I have two remarks here. The first one is that Amazon, since the beginning of the survey 65 million years ago, it is a history of technonism and climate changes. But now, with this evolution, how do we explain gigantic biodiversity in the region and extremely sensitive to temperature, for example? Many species in the Amazon live in the limits of their thermal windows. It is the case of the fish. Somehow this hides a vast number of information that we don't know about. Biodiversity is not only shape and color, it is also a diversity that is hidden. And one of the main concerns with what is being hidden is the zoonosis, that I think that we need to put an eye on that. So I would like to hear from you about that. And the issue of science communication living in the Amazon, where we have around 30 million people, I think that when we generalize this, we need a long-term policy and a state policy for the communication of science. We are very good at communicating biodiversity and what is hidden behind it to our peers, but we need to decode that. We need to put in fact the science in the society's lap. We need a continuous action to take this information considering the diversities, the cultural and social diversities that we have in the country. Don't you think that?
Well, in the Amazon, it does have a history of tectonism. So we see a large portion of its biodiversity associated to the Amazonic drainage. When we look at ecological aspects, we see that that is also associated to that. So it's a mixture of aspects and factors. This history of over 60 million years, there are many factors. So I completely agree. In the latest studies, the formation of Amazonic drainage has been demonstrated as an important factor. So we don't have those large mountain ranges in the Amazon, and the formation of the drainage has been a factor to explain the origin of many species. Well, there are so many hypotheses, but that only shows how little we now know. And the overview that I showed is a hypothesis with the available data that we have today, based on different organisms, and we need a lot more study, including geological studies and biological, climate, space studies, for us to obtain a more accurate overview. I agree with your point about communication that needs to be addressed more effectively throughout the country, but I also want to point out the loss of traditional knowledge that is going along the loss of biodiversity, be it in land or in the oceans, or those who work with traditional populations see that these specialists have been decreasing. There's a lack of valuing of that knowledge. And if we lose all of it, it will be a tragedy. So this needs to be incorporated in research projects. To incorporate these people and acknowledge them as researchers in their category, there are some barriers. There are ways, but I think that is also a pathway for us to explore. And to make that connection again, Adalberto, I agree. We need to teach, we need a transversal inclusion in education for that, because we researchers will always fall into that issue. We need to know more. And those who are making decisions or creating policies say we have to make a decision now. COP lasts 15 days. We're deciding what's going to be happening across 50 countries for the next 30 years. So we need that type of preparation so that when we get there, we will still be collecting, but the decision will be made now. Then you keep collecting, but this needs to be clear. Of course, here I'm talking to scientists. The base of all of that will be scientific education for society to not just know how to communicate that, but be aware of the importance of what they're talking about. So we have an international guest who's already waiting in line, I believe. Marcelo, no? Okay. Okay, you won't. Thank you. Forgive me. The theme is very relevant. There's a lot of possible debate. We will write these down as demands for the future seminars. Again, thank you so much to our three panelists who gifted us with brilliant presentations. There's a lot to reflect on. They were able to make a very accurate synthesis in a very short time of Brazilian biodiversity, what we have and what we need to do. Thank you again. So let's kickstart our keynote address. And I have the great pleasure of introducing our speaker, Professor Chris Field. He's director of the Stafford Words Institute for the Environment and is also a professor in interdisciplinary environmental studies. He's one of the great names of worldwide ecology, and his research is focused on climate change, and especially in solutions for improving quality of life, for mitigating climate changes, as well as supporting economic development. His most recent projects has focused on risk reduction in coastal regions, as well as risk reduction of great forest fires. He founded the Carnegie Institution. He was also a co-chair of Work Group 2 of IPCC in its fifth cycle of evaluation, and coordinated the elaboration of the most recent report of adaptation to climate change. His scientific work is highly regarded and acknowledged globally, including his election for the American Academy of Science, the Russia Medal Medal, and has also been awarded the Japan Award recently. It's a great pleasure for us to receive you here today. The floor is yours.
Thank you so much, Professor Bustamante. It's a wonderful honor for me to speak with you today.
Obrigado, professora Bustamante. É uma honra para mim falar com vocês e também é altamente conveniente poder vir eletronicamente. A Universidade aqui de Stanford está localizada numa terra indígena de alta importância para povos indígenas e consistente com nossos valores, temos que tornar visível nossa relação com os povos indígenas também. E o material que eu quero compartilhar com vocês hoje tem a ver com a relação entre soluções climáticas e a natureza. Especificamente, eu gostaria de explorar o ponto até o qual nós podemos utilizar a própria natureza para solucionar a mudança climática e colocar ênfase no que precisamos fazer para facilitar o potencial que a própria natureza tem, especialmente em regiões tropicais. Os 4 tópicos que eu vou abordar hoje são: o primeiro é termos clareza sobre os desafios, especialmente o fato de que as emissões de CO2 precisam chegar a zero. Isso é algo que é uma necessidade fundamental. Assim como a busca pelo depósito desaparecido, um depósito que significa o quanto que a natureza pode contribuir para a absorção desse CO2. Como proteger esses depósitos. E depois finalizarei com algumas observações sobre soluções climáticas naturais. O que podemos fazer para melhorar nossa remoção de CO2 e como a natureza pode nos auxiliar nisso. Podemos utilizar formas de identificar essas formas, como avaliá-las e por que é importante que isso seja integrado às agendas locais. A percepção de que as emissões de CO2 precisam chegar a zero é uma das maiores descobertas da ciência climática da última década. E essa relação essencialmente linear entre as emissões cumulativas de carbono desde o início da Revolução Industrial e a quantidade de aquecimento dentro desse sistema climático dita o quadro atual.
over 27 years. If we do the same exercise for a 66% probability of limiting warming to 1.5 C or less, the shocking result is that we have less than 8 years left before the entire budget has been used up if emissions continue at the current pace. If they grow, that time, of course, is even shorter. Here's another way to look at the rapidity with a linear fashion. That means that emissions need to go from the current level to zero by about 2086. And you can see that the pace of the decline needs to be almost twice as fast as the pace of the emissions growth during the 20th and 21st centuries. If you do the same exercise for a 66% probability of limiting warming to 1.5 C, almost shocking conclusion that emissions need to drop from the current level to zero by the middle of the
Até
2040s.
2045.
I think it's exceedingly unlikely that we will be able
Extremamente
to
improvável
limit warming to 1.5 C.
que
And for the
possamos
rest of my
limitar o
remarks,
aquecimento a
I'll
1,5
focus on
graus.
this 2C target,
Eu vou focar nessa meta de 2 graus e por que ela me parece ser o ponto ideal em termos de viabilidade. Há muito tempo tem sido claro para nós que este orçamento possuía um depósito oculto. Havia uma expectativa de que a quantidade de CO2 na atmosfera, no final de cada ano, deveria, de certa forma, ser igual à quantidade de emissões menos o CO2 que é dissolvido no oceano. E Keeling e outros nos anos 70 perceberam que esse equilíbrio não correspondia à realidade e que deveria haver um depósito secreto que estava removendo o CO2 da atmosfera. E após décadas de pesquisa, nós percebemos, mas ainda não entendemos completamente esse depósito. Meu grupo fez décadas de experimentos expondo terras a níveis altos de CO2, procurando aonde que estava o carbono extra, que resultava na fertilização do CO2, percebendo que em certas condições nós emitimos mais carbono, em outras menos. Também colocamos muito esforço na compreensão dos padrões geográficos do crescimento de vegetação pelo mundo. E chegamos à conclusão inescapável de que a fonte das maiores taxas de crescimento de vegetação anual são, e percebemos a localização desse depósito. Começamos a
por causa dos efeitos de insetos que estavam bem proeminentes. A tecnologia para identificar essas fontes ficaram ainda melhor nos últimos 20 anos. E esse artigo recente de Harrison et al. Mostra de forma espetacular a escala espacial com esses dados milimétricos com fontes de onde estão os carbonos. E é uma indicação importante de que nós já estávamos vendo a cessação de algumas emissões de carbono, assim como na Amazônia. E isso foi reforçado de um artigo maravilhoso de GATT que foi publicado no ano passado, que mostra do sudoeste da Amazônia, que mostra que como o ecossistema funciona como uma fonte líquida de carbono na atmosfera, independentemente da perda de biodiversidade que foi destacada e com a vulnerabilidade desse depósito oculto e com as mudanças climáticas e outras intervenções humanas. O que eu quero fazer agora é passar alguns minutos mostrando esse depósito oculto e caracterizando o que...
And I want to change the language here because the sink is no longer missing. We know with the easy to see. The background sink is the green wiggly line. It has a lot of variation through time. It's grown consistently from the middle of the 19th century until the present, such that the fraction of carbon dioxide that remains in the atmosphere has stayed pretty close to constant as a result of parallel growth in emissions in the ocean sink and in the land sink. If we look at the cumulative totals for each of these three over the last decade, the conclusion is that in the order of 45 to 50% of total anthropogenic emissions of CO2 have remained in the atmosphere, and the other fraction, around 55%, a little more than half, has been partitioned between the oceans, about 23%, and ecosystems on land. At 31% of total emissions that I want to speak to for the next few minutes. These background sinks are massive free subsidies from nature, huge relative to all the other things we have talked about as climate solutions, and a really key part of the way the carbon cycle works now and our prospects for dealing with climate change. Some aspects of the persistence of this background sink are well understood, but many aspects are poorly understood. So in particular, we don't have a good sense of when these land sinks will saturate, if they'll saturate. We don't have a clear sense of the sensitivity to a changing climate, although recent research in Brazil has been extremely informative. And we also have limited knowledge about the prospects for protecting these background sinks. Let me present a conceptual model that provides an entry point for thinking about the mechanisms of protection. We can think of two fundamental conceptual models under which the background sink might operate. In a silo model, it has a fixed capacity, and we are mainly talking about refilling stocks that had been depleted as a result of previous human actions, especially land use change. With a haystack model, where you can imagine just piling more and more and more hay on a stack, there's really no limit to how big the stack can be. And if the background sink is driven mainly by CO2 fertilization, you might expect that the magnitude could be almost unlimited, or at least until the system runs out of another resource, nitrogen or phosphorus. And consistent with these two conceptual models, if the silo model is mostly correct, we would expect the extra capacity of the biosphere to be on the small end, maybe order of 100 billion tons of extra CO2 that could be stored. If the haystack model is fundamentally correct, we could be looking at CO2 storage at the large end, perhaps as much as 1,000 gigatons of carbon dioxide equivalent. So what can we say about where we expect to be with relationship to the at least the silo model? If we look at the amount of carbon that's been released to the atmosphere over the time that we can do accurate accounting as a result of land use change, that number is around 750 billion tons of CO2. And if we just add up the land sink over the time period that we can do accurate accounting based on the figure that I showed earlier, we can conclude that we've seen an uptake of about 500 billion tons. And if the silo model is correct, we would expect the difference between those two, in order of 300 billion tons, to be the extra capacity of the biosphere until we run out of capacity. So what can we do to protect the background sink? By far, the most important intervention is to limit climate change. The second most important intervention is to limit climate change, and the third is to limit change. There really is no alternative to the importance of limiting climate change for protecting nature's massive subsidy. And I want to emphasize that this is nature's biggest contribution to climate change solutions. It's something we've gotten for free. We've never had to engineer. And without it, we are in an incredibly deep hole in terms of addressing the climate challenge. I want to talk for the next few minutes about natural climate solutions and the extent to which they can build on the background sink, which hopefully maintained at close to or at its current level. So natural climate solutions can help us in decreasing emissions, either from deforestation, agriculture, or other land use, or they can help us in increasing removals through a whole bunch of interventions, from improved forest management, reforestation, to doing a better job protecting soils and agriculture and coastal ecosystems. It's one of the great features of natural climate solutions is that there are abundant opportunities for win-wins. It can be a mechanism for protecting biodiversity, habitat, ecosystem goods and services, and supporting the lifestyles of indigenous and rural communities. But there are important costs, and those include the reality that some kinds of development opportunities need to be foregone. These interventions require large amounts of land and water, and they prioritize some visions of a sustainable future over other visions. What's the global potential for natural climate solutions? The place we often start the conversation is with this 2017 paper from Brunson Griscom and colleagues, which identifies the major potential in forests, either reforestation or avoided deforestation. And Griscom and colleagues also identified the opportunities where they felt that there were big things to be done at manageable cost, with the light gray bars indicating expected costs of less than $100 per ton of CO2, and the dark gray bars indicating less than $10 per ton of CO2. And it's very clear from this figure about technical feasibility that the big bulk of the lowest cost solutions were expected to be in avoiding deforestation, of course, mainly in the tropics. A whole bunch of studies have tried to do similar calculations of how much carbon removal is possible. And if you look at all of those studies that had been published as of last year, they're arrayed here relative to the orange banner, which indicates the interquartile range in the IPCC 1.5 report of the amount of carbon removal that are going to be necessary for having a 66% probability of limiting warming to 1.5 C. And what you can see is that some estimates suggest that natural climate solutions could fill all of this need for carbon removals, and many other estimates indicate that there's a lot less potential in nature than is going to be required. The The Griscom et al. Study that was in the last slide is a very, very optimistic one. My sense is that if we look at the average across these studies, that's a much better indication of the technical potential. And the technical potential is clearly very optimistic in terms of the widely acknowledged political and economic challenges that are associated with activating carbon removal. If we return to the historical picture of how much carbon has been lost from land use change in the past, compare that with the land sink that's occurred already, the expectation is that the total remaining capacity for sink should be the difference between those two on the order of 300 billion tons of CO2 equivalent. And if we take all the published studies that were in the last figure and ask what's the average amount of storage that they project, it's in the neighborhood of this 300 billion tons of CO2, which is kind of an outside check on the estimates. And it indicates that, at least in terms of technical potential, we should aspire to see something between 0 and maybe 300 or 400 billion tons, recognizing that the politically feasible, economically feasible numbers are likely to be substantially smaller than that. So why don't we just deploy these natural climate solutions? First, it's important to recognize that they're fundamentally different from emissions reductions in the sense that ecosystem carbon is inherently susceptible to later loss in a way that emissions reductions aren't. And they also are beset with three widely discussed and relatively well understood challenges. Permanence, how long will the carbon stay in the ecosystem? Leakage, does protecting of forest in one place mean that deforestation or harvesting simply moves to another part of the world? And additionality, how can we know that, particularly with avoided deforestation, that a protected forest is protected as a result of our interventions and not simply a place that would not have been deforested as a result of many other kinds of factors? A lot of this is coming into focus in the area of carbon markets. There's really a surging interest, especially for companies to be able to report progress on their net zero goals. In 2021, there was about $300 million of investment in carbon offset markets, and it's projected to double within the next few years. But there are also growing worries about the quality of these carbon products based on limited transparency and questionable quality, on protections that aren't there, and the pressure from commercial purchasers to have the lowest possible price, which has in many ways been regarded as a race to the bottom, not only on price, but also on quality. And so it is really important, if we want to capitalize on natural climate solutions to be aids in the progress on tackling climate change, we need to get these markets in order. It's really a global issue that we're seeing a wide commitment to participation in these carbon markets, projects around the world. And we need to figure out what we're going to do about it. Let me speak first to this question of permanence. And one of the things that's really striking is that permanence, the consistency with which forests have persisted historically, has been much greater in the tropics than at high latitude. One of the really great challenges is the concern that we're already seeing climate change impacts in tropical forests, including Brazil, where the permanence is getting to be substantially less. Of course, in temperate ecosystems, we're already seeing dramatic indications of a loss of permanence associated with a rapid increase in wildfires, especially in the American West. Leakage is a huge problem. A lot of the estimates of leakage as a result of avoided deforestation are as high as 75 or 80%, especially in areas where the deforestation is driven by demand for timber for international markets. And until we can figure out how to manage leakage, potentially through plantations or other mechanisms, we need to be really wary about crediting avoided deforestation projects with the full quantity of carbon they protect, recognizing that we may be seeing accelerated losses in areas that are outside the jurisdiction of an individual project. These two concerns about additionality and permanence have led to grave concerns about whether carbon markets are viable. And lots of recent press has indicated that the reliability of these markets is too low to warrant participation. A huge problem for nature, because many of our opportunities for protecting nature really intersect the prospects for viable carbon markets. So when we look at how we can improve these markets, there are roles at many different levels. International organizations can help standardize the rules. Nations can help make sure that the legal protections are in place. Companies can recognize that they will need to pay more for carbon products that are transparent and credible. Landowners need to recognize that their participation needs to involve commitments to long-term stewardship that are not the norm in many parts of the world. And communities need to be included so that around the world, the local citizens are engaged and benefit from the kinds of protections that are necessary in order to support these carbon markets. An additional element that I think we're underappreciating is the challenge of double counting. We know that current emissions are a mix of emissions from energy and industry, as well as those from agriculture, forestry, and other land use. And we know that there are these incredibly important background sinks in the land and ocean. And we know that in order to bring carbon emissions to zero, we ultimately are going to have to rely on large amounts of decarbonization, stopping emissions from agriculture, forestry, and other land use, and removing carbon, especially with natural climate solutions. In the national accounting system, it is authorized under the managed land proxy to count some of this background land sink as part of a national inventory. And in terms of what the atmosphere sees, it doesn't much matter whether it's viewed as a background sink or as a part of the decarbonization path. But for the carbon markets, it's really, really important. And one of the developments that concerns me greatly is seeing efforts to include the background sink in deliberate efforts to decarbonize, when in fact that's straight double counting. And we need to recognize that protecting the background sink is a responsibility that we have independent of the role of market forces in prioritizing it. So what is the solution? I think that the key principle that we need to shift to in enhancing and developing these markets is to promise less and deliver more. We need to recognize that permanence, leakage, and additionality will always be problems. And we need to activate a whole new range of solutions that allow us to credibly deliver solutions that the atmosphere will see that don't depend on uncertainties about permanence, leakage, and additionality. In particular, that will involve things like setting aside relatively large buffer pools so that later losses can be compensated, and strategies like issuing only partial credit to address the fact that our accounting for additionality and leakage is still far from complete. We also need to have much more robust standards than we currently have. They need to be science-based, they need to be public and transparent, and they need to be verified by qualified and reputable entities. Now, the third thing we need is high levels of community engagement. And we need to recognize that even with the presence of strong national laws, the sort of intensity of local public support is really going to be critical for the prospects for long-term management. And we need to recognize that community engagement needs to be really cultivated. It may require economic payments, but it certainly requires a co-development of these carbon projects. There's, of course, lots of action on these natural climate solutions and many well-intentioned, well-funded projects moving forward. But I'm concerned that the work to date has focused on identifying the very best carbon projects where concerns about permanence, leakage, and additionality are least, when what we really need to do is embrace and acknowledge the fact that the areas most important for conservation will have significant issues with permanence, leakage, and additionality. And we need to put the structures in place so that those sites, the most important sites for conservation, are also useful in these carbon markets. So what's that look like in terms of the promise of natural climate solutions? The key really is to link three important but really different kinds of considerations. When we talk about the effect on climate, we really need to be able to see this in terms of the effects on the atmosphere. We need to find ways to mobilize markets where conservation criteria are most important, in biodiversity hotspots, in places of cultural and ecological importance. We also need to recognize that this is never going to work unless local communities are engaged from the start of the process through the end, and we need to mobilize communities as guardians of the climate conservation nexus. So what does that mean in terms of the overall conclusions? And I want to leave you with two really simple thoughts. The first is that background sinks are absolutely central to achieving our climate goals. And at least for me, there's no stronger motivation for sticking to ambitious climate targets than the maintenance of these background sinks. Without them, the climate challenge gets to be harder and harder, and I would argue insoluble. But we also have really big opportunities for deploying natural climate solutions, both in the context of countries meeting their nationally determined commitments and in terms of opening up a range of solutions that are accessible to companies and individuals around the world. We need to work really hard, though, to make these natural climate solutions fulfill their potential to address the needs of climate conservation and communities. With that, I'll stop, and I would love to hear your questions.
Thank you very much, Chris, for this excellent presentation and for finding time to be with us today. So we have now some time for questions in English or Portuguese, as we have simultaneous translation. So, Professor Luis Davidovich, President of the Brazilian Academy of Science.
Thank you very much for your very interesting talk. I do have a question about what I believe is another factor in climate change and pollution of the air, which is methane. Methane. Could you comment on that?
Sure. So CO2 accounts for about 75% of the current climate forcing, with other gases, especially methane, contributing the other quarter. Methane is important because it has a much higher global warming potential than carbon dioxide, but it's also interesting because it has a much shorter half-life in the atmosphere. Half-life's only on the order of a decade or so. So decreases in methane emissions have the potential not only to limit warming, but to actually lead to cooling. And if we could bring methane emissions down to zero, we would see a substantial decrease in the radiative forcing of climate and a decrease in the amount of warming that occurs. From my perspective, the question of tackling methane versus CO2 isn't either or. We need to tackle both, and we need to be ambitious about tackling both. The recent evidence from methane sources indicates that a really large fraction comes from the oil and gas industry. A substantial fraction comes from wetlands, either natural or managed wetlands. And a really substantial fraction comes from animal agriculture with ruminants, especially cattle. And at least for me, a really key feature of tackling the climate challenge is that while we should be tackling everything at the same time, we don't need to be making progress at the same rate on everything. So in the methane space, there are obvious cost-saving things to be done to limit losses of methane from oil and gas operations. Agriculture is much more difficult, and I think at this point, progress in decreasing methane from rice agriculture and from ruminants is really a work in progress, and we need much more research before we even have a clear picture of where the best opportunities are. It definitely warrants a huge priority and emphasis, but we need to recognize that we're in different places in our ability to tackle different processes and different greenhouse gases.
Thank you, Chris. We have now a question from our remote audience. It's from Larissa Macedo, and she's asking about the community engagement and how we can cultivate it without government support.
This is a great question, and it's so important for the activation of natural climate solutions around the world. And I won't pretend to have any insight into the opportunities and challenges in Brazil, but my experience in the IPCC and in my own work points to the huge amount of variation in the objectives and the capabilities of communities around the world. In California, we've seen some really incredible actions recently where indigenous groups have found a way to repurchase some of their traditional lands and are using the carbon markets to make the payments on the lands that had been theirs traditionally and are finally theirs again. I think from my IPCC experience, the one commonality in terms of community engagement is that for there to be a prospect of it being effective, it has to be a priority from the start of the process, and it can't be added on at the end.
Thank you. I have a question also, Chris. I understood from your presentation that you don't believe in the 1.5 target anymore. So
it's not that I don't believe in it, it's that I don't believe it's possible to achieve in the political and economic world of 2022. Your work with the IPCC has been totally convincing that the 1.5 C target is technically feasible if we could transition to rapid and large decreases, decreases in emission using technologies that are already available. But I don't see us taking any of the steps. One of the things that's made me rethink the challenge of 1.5 is the time that's passed since the important IPCC 1.5 report, which is now almost 4 years, where the emissions trajectory hasn't changed meaningfully, except for the blip that was caused by the COVID-19 pandemic. And I think that even though we're seeing solid progress in many countries and have a lot to be happy with about the way the climate action is evolving, that we're not seeing anywhere near the level of commitment or ambition that'll be required for 1.5. I would love to see stabilization somewhere close to 1.5, but I think as a question of management and particularly of adaptation, we need to be realistic that adaptation targets should be focused on substantially higher values of warming. My personal feeling is that we should be designing adaptations and thinking about things like protecting background sinks for a warming level that might reach as high as 2.5 or even a little higher. That's not to say I think that's where we should go. I think it still is practical and feasible to be very close to 2C, but we need to build in a safety margin so that our adaptation actions and our adaptation interventions can continue to be effective.
Yeah, this is a particular critical problem for developing countries when you think about financial flows for adaptation and adaptation gaps that are still.
And for sure, and you know, I don't pretend to understand why, especially the rich countries, have been so slow to recognize the critical importance of financial flows for adaptation.
Thank you. We have now another question, Professor Elena Nader.
Thank you very much for your wonderful talk. I was just curious regarding one of your slides. I think there was a map where the absorption of CO2 by the tropical forests are much higher than when you look at, for instance, forests in Australia, New Zealand, cold areas. Do we have a clear explanation for that? Is it related with the weather conditions?
Right. The map I showed that had the very high plant growth in the tropics was what we call net primary production, annual growth of plant and annual accumulation of plant biomass. And the wet tropics around the world are widely understood to have the highest rates on an annual basis, mainly because of the year-round growing season. And if you look at the highest monthly rates in Europe or Eastern North America or even Eastern Australia, the highest monthly rates can be as high, but over a much shorter growing season. And having high rates throughout the year means that in especially the wet tropics, annual plant growth is typically about twice as high as it is anywhere in the temperate zone.
Thank you. We have another question from the remote audience. It's from Lucas Coraza. It's also about finance. So the bottom line is getting conservation and restoration plus natural climate solutions. Trillions of dollars throughout decades and tailored plans for communities. Is it possible to unlock huge amount of money and make it?
I wish I knew the answer to that. You know, I think that we live in a world now where climate security is every bit as important as military security. And, you know, we have cultures around the world, nations around the world that are willing to make major financial investments in in military security, and the understanding that needs to evolve is that climate security requires the same kinds of investments. I wish I knew whether or not it's possible to see that happen, but I think it is so overwhelmingly clear from the evidence that the sustainability of our planet is going to depend on substantial financial flows from the rich world to the poor world. And I just don't see us solving the problem unless we can mobilize those.
Thank you. And last question here. Okay. 2 questions still. Professor Alvaro Prata, please.
Thank you very much for your wonderful presentation and a very stimulating talk. My question is, well, we know that the background sink, the land background sink is decreasing. And how about the ocean background sink over the years? How is the ocean background sink varying over the years?
That's a great question. And the processes controlling the ocean sink are in some ways simpler than the processes controlling the land sink. And the big driver is the concentration difference between the CO2 in the atmosphere and in the water that's coming to the surface. And of course that the amount of new water delivered to the surface every year depends on the large-scale ocean circulation, which is of course climate sensitive. But because the ocean sink is fundamentally driven by this concentration difference, when CO2 stops rising, when we do get emissions down to zero, eventually the ocean sink will go away as well. It will persist for some time as a result of the ocean circulation delivering water to the surface that hadn't, last saw the atmosphere a couple of thousand years ago. But eventually that will equilibrate, and we will see a gradual decrease in the magnitude of the ocean sink. That was a super oversimplified explanation because there are many other biological, chemical, and physical processes that contribute, but the long-term expectation is that once we get to zero emissions, we'll see a gradual decrease in the sink.
Thank you, Chris. We have 2 final questions. The first one, Professor Adalberto Val, and then Professor Glaucius Oliva.
Thank you, Mercedes. Thank you, Professor, for your very nice talk. Browning surface waters are one of the consequences of increased CO2. How that would affect water security for human use in the future?
Changes in the water cycle are super complicated and super important around the world, certainly as much in Brazil as in other regions. And of course, the impact of carbon dioxide on most ecosystems is to make them more water use efficient, to decrease rates of evapotranspiration, potentially leaving more of the water in the soil or more to run off. But we also know that many of the changes we've seen in ecosystems have led to an increase in leaf area index, or increase in leaf area, which tends to increase transpiration. So in most places, the effect of a higher CO2 warming climate on water resources is a greater limitation as a result of the increase of evapotranspiration over precipitation. And I think that Brazil with its current drought, or California with its current drought, are really at the harbingers of much more serious water resources problems that we'll be seeing in many, many parts of the world. And we used to argue that there was a general pattern from the climate models where a warmer climate led to more precipitation, and that you would expect the areas that were already wet to get wetter and the areas that were already dry to get drier. But the most recent IPCC reports show that's really not the case. And some areas that currently receive large amounts of rainfall, especially in the Amazon, are expected to dry in the future. So I think one of the strongest arguments in favor of limiting the amount of climate change that occurs is water security throughout the tropics, but especially in Latin America.
Thank you.
How do you see the impact of new technologies in reducing CO2 from the atmosphere? Just like, I mean, engineered bacteria or electrolysis or other processes for carbon sequestration?
I think that we have seen some really promising developments for engineered carbon dioxide removal. And currently most of those technologies are still too expensive to be deployed at scale. And the energetics suggest that the costs aren't going to come down rapidly and dramatically. But I think in the climate space, we should be working on every option that has the prospect of being helpful. And these industrial carbon dioxide removal options are attractive enough that they really should be priorities for research and priorities for seeing how much we can drive the cost down through early applications.
So, Chris, thank you very much again for your participation here. It was great to see you again. Excellent talk, and I hope that we can improve the dialogue between the U.S. National Academy of Science and Brazilian Academy of Science in the near future. Thank you so much.
Thank you so much for the opportunity.
Bom, com isso, então, nós encerramos, né, o primeiro dia da nossa reunião. Gostaria de agradecer a todos novamente pela presença aqui e aos nossos organizadores, professor Glaucius, Oliva e Alvaro Prata, pela oportunidade. E amanhã, às 14h. Reforçando, hoje foi só a exceção pelo horário aqui, pela questão do fuso horário. Muito obrigada e boa noite a todos.